In this video, I'm going to try and work from start to finish or field to finish from an imported data file from a logger of sorts, all the way through to a final presentation PDF or DWG. I'm going to do my best to try and go through most of the common features of Enforce that you would normally want to visit in terms of processing survey data, traversing it or least squaresing it, generating a model, editing it, tidying up your features, tidying up your text, creating a DTM, editing the DTM, creating the contours, annotating the contours, generating a layout, and then maybe some sections as well to finish with. So that's the plan for this video. So that you know what version I'm on at the time, I'm using a 4.4D from the 17th of April 2026. This isn't a version that's been fully released yet, but I will make this version available to go with this video. So I'm going to start just by quickly showing where the standard settings are. So if I go up to settings, the main settings that most people would want to be familiar with to begin with are the layering system. Okay, and these can be brought in from an existing DWG. Okay, so if you wanted to bring them in from an existing Cadd drawing, okay, let me just quickly show you how you would do that. So I'll go to the Cadd part of Enforce. Okay, now you can either right click or import, or you can just drag and drop. So off screen, I've got some data here. This is our training data, and I'm just going to take this file here. All right, and it's a DXF, but it could be a DWG, it doesn't really matter. And I'm just going to drag and drop. Okay, and we're just going to leave these options as they are for now and just press OK. So what I'm really interested in these layer names. Obviously, they're horrible, hideous layer names, but this is literally just to prove a point. So I'm going to double click the pencil icon and go to the layer button. All right, and here you can see all the layers that are in this particular Cadd file. So let's say, for argument's sake, I wanted all of these to be added to my project so that my code table can see them. So if I hold down Shift, select the last one, you just hit to Project. You get this great big long dialog box now, which could go off the screen because there could be so many layers. If it does go off the screen, all you have to do is just press Enter. So if I cancel that now and then go back into my settings and go back into layers, there you go. Here are all those horrible layers. And if I were to go into my code table, I could then start the laborious process of actually reassigning parts of my code table to use those horrible layers. Now, obviously, I don't want to do that, but I just wanted to show you that that's how you would proceed. Once you've made changes to the system that you want to be permanent, you would then go to Layers, for instance, and then press Save. Likewise, on the codes, you'd go to File and Save. That saves the settings so that the next time you start up Enforce, these settings will be there. Another way of approaching this kind of task would be, once you've got your project set up the way you want, delete everything you don't want out of it, like say for instance deleting that Cadd drawing, go to Symbols, go to Purge, make sure it's going to only purge symbols that you don't want it to use, because these ones come in with the DWG or the DXF. Okay, and then you could go File and do a Save As. Okay, then call it whatever.sdb, and then you could put that on your desktop as a template. And then when you double click that SDB, all the settings will open up straight from that file. It won't actually use the settings on the drive that you would normally use when you first boot up Enforce from an icon. Okay, so you can create a template project or go into the various save options on each of the main settings. So that was said and done. I'm just going to go to New and start again. So I'm just using the basic settings that come shipped with Enforce. So all the problems that I encountered during this video should be the same kind of problems that you encounter if you try and do this yourself with the data that we also ship. So with Enforce focused on survey data, I'm going to go back to this training folder, which you can get through the shortcut on the Windows desktop that we put there called Enforce support files, and then go into there and then go into training. And what I'm going to do is I'm going to select this file here, and I'm going to just drag and drop. Okay. Now, if you were to select a different file, for instance, a Trimble JXL or a Leica XML, or a Topcon MXL, or whatever, you'll be given some options when you import it. It might ask you about duplicate stations, whether you want to import those. You can say yes or no to those. It might say that there are some temperature and pressure corrections that haven't been assigned. Do you want to do that? So Enforce will ask you to make some choices based on the file you have dragged and dropped. This is a very, very, very simple file. So it's only got raw survey observations. It's got no stations. It's got some raw survey observations, but it's got no coordinates. Okay, so most files that you drag into Enforce from a Leica or a Trimble, they'll contain both observations and coordinates at the same time, and probably some sort of control. For this particular example, I'm just going to concentrate on raw survey data. If you bring it in and it's got coordinates, okay, those coordinates are not linked to these observations. If you were to carry on and model those, then you are modeling the coordinates that the instrument calculated, not ones that NForce has calculated by running an adjustment or processing the raw survey data. We'd always recommend that you process from the raw survey data, because if you do that, you've always got to get out of jail card. You can always adjust your observations, make any changes to, instrument height, target height, maybe even correct for prison constants if you needed to by selecting the relevant observations and choosing offset. But you've essentially got the ability to edit your raw survey data this way. If you just process the raw coordinates that the instrument calculates for you, then that is what you're going to be carrying on and modeling. There's no kind of trail back to the observations. So that said, what I need to do is I need to at least give NForce the coordinates for our first setup, A in this situation. Now, control observations, before I go and actually process this, control observations are shown in a dark yellow or a different yellow to the background yellow. It'll say -99, so -99 is just a historical way of flagging control shots to NForce. Nowadays, you could put the word STN anywhere in the point ID or the code, and it will do the same thing. You could even actually tell NForce you'd rather use something else. So if I go into code and say I wanted to use the prefix ST instead. So you just leave it on the default here, press add, put in ST as your code, and all you're going to do is you're going to say point is control. So whenever NForce comes across a point with ST in its point ID or code, it knows that that's a control shot. Now, usually most control observations are done first. In this particular example, they're dotted around. Okay, so some at the front, some at the top, some at the bottom. So just to make it easier to see where the control shots are, I'm going to right click on the yellow book and I'm going to choose collect control. That shoves them all to the top. Okay. Now, I need to tell NForce where A is, because that's my first setup in this situation. So I'm going to say A, and that's got a coordinate of 1,000, 2,000, and 100. Okay, so I'm going to run this in two ways. I'm going to run a simple Bowditch on it, and then I'm going to do a least squares on it. So to start a simple Bowditch, what I'm going to do, I'm going to highlight the yellow book, right click, and I'm going to come down to Traverse. Okay, so because the observations are actually in the correct order, so we're backsighting the appropriate setup and we're foresighting the appropriate setup, I can just press Auto. Okay, so if it says closed, that means we are basically starting at A and finishing at A, the same point. Okay, if we were starting on a fixed point and then finishing on another fixed point with a shot to another fixed point on there, so essentially we're starting on one bearing and finishing on another bearing, then it will say control. And if we're just setting up, or rather, if at the end of the traverse all we're doing is just sighting a fixed point but never actually occupying it, then this would say pipe, because you're ending your traverse by sighting a point you know the coordinates of. So you have positional misclosure, but you don't have any way of controlling the angular misclosure. So I'm going to press next. So we're assuming start coordinates of 1,000, 2,000, and because it knows nothing else, it's having to use the back shot as a whole circle bearing. So in this case, the shot from A back to I5 is trying to treat that as a whole circle bearing. So that's 37 degrees, 48 minutes, and 31 seconds. All right. So if you know the actual bearing, you would just type it in. But what I'm going to do as part of this, I'm actually going to do this in a local grid, and then I'm going to make up some coordinates that are perhaps in, shall we say, a different coordinate system like UKOS, and then I'll show you how you would do a transformation from one to the other. So having set the bearing, what we're going to do now is just check our misclosures. So we have 44 mil in the eastings and 9 mil in the northings, and a bit of an issue in the height by the looks of it as well. But the angular error is very good. Because it's a closed loop, we know the sum of the internal angles, mathematically speaking, and then obviously we subtract that from the measured, and then that gives us our angular misclosure. So in terms of actual angles, this is a pretty good traverse. If we look at the lengths of some of these observations, they are pretty big though, so like 750 meters. So that's actually pretty good result. And it's obviously not to be unexpected to have some issues with our misclosures over shots that long. Just by using pure trig, just drag this over so it gets rid of the bar across the bottom. So just by using pure trig, we should be coming back to exactly the same coordinates. Obviously, we are not, hence we have a misclosure. So these are the misclosures before the angular error is redistributed. If I press next, we now have the angular error after the angles have been redistributed, or rather shared out, proportional to the length of each leg of the traverse. All right, so that's what that's for there. That's showing you your misclosures after the angular error has been shared out. And using the Bowdish method, we're going to create a full report, but obviously there's still an issue in terms of the misclosures. So that's what the final stage of the traverse does. So it shares out the positional misclosure, okay, based on the length of each leg of the traverse. So now we start at 1,000, 2,100, and we come back to 1,000, 2,100. I always like to separate my eastings and northings because then obviously you know hopefully which one's which just by looking at the value. That's all I do that for. That's all done now, so we're hoping our errors are small and systematic, not large and random, because if they're large and random, then we'll definitely have to use least squares to try and find out where those problems lie. So I'd normally just press finish now, and it takes us to the reduction stage. So the reduction stage is where we are taking our measured observations and comparing the distances between them against what we now have adjusted. Okay, so NForce now knows where these stations are because it's computed them as part of the traverse, and it's comparing the distances between what we've measured with our raw observations and what it now thinks is true based on whatever adjustment we've done. And that's where you get these exclamation marks. So if you see an exclamation mark, it's because it's failing a particular tolerance check. If I was to set those, say, to 10, 10, and 10, then the number of exclamation marks goes down. You can see, so that one's just failing a height check. Same as that one. That one's got a slightly larger check in the distance, which is basically just the 3D error of the easting, northings, and the height. Okay, but these two pass. If I set it something small, like a monitoring job would have, then obviously you can see that they're all failing. So it's up to you to set those tolerances according to the kind of what you want to do. If I press OK, it'll say, are you sure you want to continue? We've still got some issues. You can obviously say yes or no. Just for this situation now, I'm going to just obviously OK that, and then you get the text report up. So the text report just backs up everything that's done. It shows you your average observations if you're doing rounds of observations, and any spreads from those will be highlighted for you. And obviously then you can scroll down the report. You can see if any corrections were applied, the raw traverse data, your misclosures before and after the angles were distributed, the computed traverse, and then we get into the actual reduction stage where you're going to essentially see your RO reviews again. This can all just be saved to a file, or you could export this to an Excel spreadsheet. Okay, so I'm just going to pop those in this folder here I just created temporarily. If I say yes to looking at that, this is what we see. Okay, so it's all backed up there and presented for you nice and neatly. If you wanted to, then you could go into the settings here and use this interface to actually configure the way it looks. But I don't want to do that for now. So what's happened now is if I click on stations, we actually have some station coordinates. Okay, so it says adjusted because it's been calculated as part of a traverse. And I2 has been derived because if I click on it, it's only got a backside to A. Okay, it's got no foresight, so it can't be used in the adjustment. It's just literally a dogleg from A. But that's computing these stations using a Bowdish traverse. What if we wanted to be a bit more thorough and use least squares? So I'm going to delete those out. And if you do any kind of adjustment, whether it's traversing or least squares, you must delete the station coordinates out of NForce that you wanted to calculate. We're not actually deleting the setups. We're just deleting the station values for those setups so that NForce is able to recreate them. So to start with, I'm going to right click on the yellow book and come down to least squares, new. It says one or more of our backsides or foresights is exceeding a standard error check, so we're just pressing OK on that. So if I go to the average data, okay, and just hover over here, you can see that this particular setup, for some reason, has got a difference in the mean of the backside and foresight of about 5.7 mil. So I don't know why that is, but everything else seems to be within tolerance. If you have any larger errors here, you can obviously, they'll be colored in red, and it will then flag any up if they are outside tolerance. So if we go back to the control listing, we're going to start from A, go to I5, and we're just going to, for this instance, just set our back bearing to 0, because ultimately we're just going to make up some new coordinates for it and do a transformation. So its initial bearing isn't important. And for now, we're going to do it in 3D. We go to the settings. So just in terms of the weights, we're just allowing 5 seconds for the horizontal angles, 10 for the vertical, and 5 mil in the horizontal distances, and 5 for the part per million. So those settings are generally okay for a topo survey. All I need to do is just press adjust. Now, for a least squares adjustment, this sigma 0 value, or the total error factor, should be, statistically speaking, around about 1. If it's less than 1, it means that your weights, the amount of movement you're allowing for, is essentially you're allowing too much. Your survey is pretty good. You don't need to allow so much movement. If it's significantly above, say 1.5, then you've probably got a problem. Obviously, we have a much larger error than 1.5 here. So if we look at our residuals down here, you can see that our largest residual correction, the amount of it's had to correct this individual observation, is only 7 mil. So that's not actually that bad. Horizontal angle correction is slightly larger, and we have a much larger vertical angle correction. So this is why least squares is so much more thorough than a sort of a Bowditch adjustment, where you're not just sharing the angular error and the positional error out proportional to the length of each leg of the traverse. Okay, so in that situation, if you make a mistake at one of your setups, they all suffer. Whereas in least squares, that's not the case. All the observations have to be in tune with each other for a successful adjustment, or rather, to get a value close to 1 in any way. So we're doing this in 3D, so let's have a go at going back to the Control tab, and if I just untick 3D, and we'll just see if it's a height issue, probably an instrument height or a target height. So hit adjust again, and there we go. You see it goes straight down to 1. So if I go back to the Control tab, put it back to 3D, press adjust, and if we look at the map, you'll see we've got some pretty large error ellipses. Okay, so these indicate the setups where there's a reasonably large error. They are being scaled up 1,000 times, otherwise you wouldn't see them. So in an ideal situation, we'd have an observation coming across here to help tie that in. And that's one of the other main advantages of least squares. You can throw in as many control observations as you like, and they'll all help strengthen the adjustment, whereas in the Bowditch, we're just sort of going around the outside. In least squares, you can throw in as many control shots as you like. They could be to control targets set up out here, on the sides. You don't have to set up on them, just have multiple observations to them, and that will help tighten the adjustment for you. So if I go back to the control again, untick 3D, run the adjustment, see it goes back to 1. If I go back to the map, and there we go, we've got nice small error ellipses. Everything it's just done is put into a report that we can then keep and save for later. There we go. So that kind of proves everything that's happened in the process. I'm not going to go into much more detail on that now, so I'm just going to hit save and exit. So I do want to save those coordinates, and now we're going back into the reduction stage. Okay, now because obviously I've got everything set to 2 mil, we can see that we're obviously throwing up some larger errors here. But we knew that there was a problem in the height. We saw that when we ran the least squares. By making it run in 2D, not 3D, a lot of the errors went away. So we know that there's a problem somewhere in the instrument height, or a target height probably, but that's not for the purpose of this video. The purpose of this video is to just try and process this data and draw it up. So in an ideal world, you'd have to obviously go back and figure out why that was the case. Maybe an instrument height or a target height been entered incorrectly. If that's not the case, then you might have to go back to site and redo some of the setups. But for now, I'm going to just press OK. Yes, I'm happy with those issues. I'll just close that down. So now if I click on the setup, you can see we've got computed values now in these columns. But you cannot change them. If I try and type some numbers in, nothing happens. Okay, they're grayed out because they are linked to the observations. If I make a change to the observation, then they will change. So if I was to do something like take a series of target height, right click here, and if I was to hit set, and instead of having 1.6, I just put in 2 meters, watch what happens to the heights. Okay, those change. If I do Control Z, that'll undo. Alright, so you've still got that umbilical link. Okay, if you make a change to the raw data, these coordinates would update. Okay, and like I said before, if you brought in a survey file that had already got computed coordinates in it, and they were located under coordinates here, by changing these observations, those coordinates would not update. Okay, whereas in this situation, these will. So you've always got the ability to try and troubleshoot any problems that may have occurred on site because you're dealing with the raw data. If I double click on a single setup, Enforce will draw what was observed from that setup. We've got the scale at which we're working at the moment, which is 1 to 500, and all that really does is essentially size the text. So if I go to 1 to say 5,000, you'll see some text everywhere, but obviously we're not going to work at that, so I'll just put it back to 1 to 500 for the moment. Now, if I was to do multiple selections, say that one, and that one, and then go home, and then do full screen, it shows me what was measured from those setups. If I double click on the yellow book instead, it shows me everything. Okay, and when you're in this mode, okay, we can turn objects on and off down the side here. So I can unclick the point markers, they'll disappear. If I wanted to hide any of the line work, I can hide that. Okay, so you'll have these options down the side at all times. You have your pick mode here, depending on what you're doing, your lock mode here, and your scale there. We'll come across these other settings later. Another one you might want to change is whether you want to work on a black background or a white background. But for now, what I'm doing is I'm going to just come down here, and if I go to survey radials and set that to control, it will then draw the main control loop. And if I was to go to detail, then you can see what you measured from where. Okay, so if you do have any issues, that also helps highlight any potential problems. So now we've reduced our data and we've got our observations, but we have only done that, shall we say, in a local grid coordinate system. So what I'm going to do is I'm going to kind of make up some new coordinates and just show you how you would transform that from one to the other, from local, shall we say, to OS. So to make up the data, I'm just going to copy it for now, and I'm going to go to models, new normal. I'm just going to call this one, let's just make it up, so it's called OS stations. Press OK, and then what I'm going to do is I'm going to right click and choose paste. Okay, so I'm going to add an arbitrary number to these easting values now, so I'm going to just say offset, and I happen to have a value in there already. That'll do me fine. And let's go to the northing, right click, and we'll offset those, put a decent value in there, and we might as well change the heights as well. So let's go height offset, and let's say I'm going at minus 45.5. Okay, so that's just done a shift. It hasn't done any kind of rotation. So let's make things a bit more interesting and put a rotation in there as well. So to do that, I'm going to double click it. Okay, and we will just have some points on the screen. At the moment, Enforce doesn't have an idea of how to draw these because it doesn't have a code essentially to match them. So it'll be using the default code. So if I went to settings and I went to codes, the default code is what's being used to draw those. So if I was to change the pen from, say, grey by clicking on it, if I was to make it yellow, because I've got a black background, that'll be good for now. And if I move that, there you go, they go to yellow. So what I'm going to do now is I'm going to do a simple rotation. So I'm going to go to points, and I'm going to go to rotate by an angle, and it says in the corner indicate the center of rotation. So let's say about that point there, and it wants to know an angle. I'm happy with that, so I'm going to rotate it by 135 degrees, 45 minutes and 22 seconds. And it then wants to know which points I want to rotate. So obviously I want to rotate them all, so I'm going to rectangle mode, click, click, and they all rotate. So if I now right click, come out of there, I now have some new coordinates for my stations. Okay, so here's my rotated points. What about if I wanted to descale them or apply a scale factor to them for whatever reason? If I was to go back to points, I can go to scale, and if I come down to all, it says indicate my origin point, so let's say that one. And if we were in the OS, in the UK, you can remove the scale factor, okay? So it's going to essentially do 1 over the scale factor, or you could scale it and shrink them down, okay? So that would allow you to either descale or rescale the points. Once you've got our data, whether it's been scaled or not, I'm going to just copy that. I'm going to go to coordinates, and we'll go new, and I'll call this one OS values. Okay, and paste that in. So, just to show you there's multiple ways of doing things in N4. So if we have these coordinates here, right, we could just re-reduce our data. Okay, but I want to show you how we can also do a transformation on a model that might be in progress. So if I right click this, and I'm going to go to create model, and we'll just say local for now. And if I go to surveys, you see it's moved the data over. So now all that data has been moved into a model. Okay, now that's all in the local grid coordinate system. Okay, if I wanted to do a transformation, okay, I need to have a mapping from here to do that. What I need to do is I need to go up to stations, okay, right click them, come down to transform, and just for now we're going to do a 2D transformation. Right, so we've got our coordinates in local grid. I don't want to have to type them all in to go to my OS values, so I'm going to hit on load, I'm going to just choose them. That's why I created the coordinate block. All right, so now we have our error, which is obviously very small because essentially I've got exactly the same points and I've essentially done a translation and rotation. And for the height, you can see it, even though it's a 2D adjustment, you can actually do the adjust height and it'll work out the average height difference and shove them up. So if I were to make a small change to some of these values, we should start to see some values coming into here. So if I go down to my OS coordinates and let's just say, instead of 39, let's put a 34 in there. And for here, for I4, instead of say 776, let's make that 78. Okay, let's see what happens now. So if we go back to stations, select all of these again, we're going to go to transform, 2D, load, pick those. Okay, all right, and now we have an error. Okay, because obviously I've been playing with the data. Now, you'd obviously expect some kind of error. Normally, if you go into GNSS, there's going to be some intrinsic error in those observations anyway. But because we've got so many here, we can actually choose to knock out some if we don't want them. So if I was to double click on I4, okay, it changes. If I was to go to I1, okay, it goes back down to 0 because those were the two setups, or those were the two stations, sorry, whose coordinates I manipulated. So if you're not happy with the error, maybe there's one or two stations with slightly more issues with them than other ones, then you can obviously try and knock them out and improve that value. I want to save this transformation. So I'm going to tick that, we'll press OK, and I'm just going to call this one 2D local to OS. Okay, so nothing's really happened apart from the fact that these have now been moved from their local grid coordinates to the OS coordinates. What you would then do normally, if you hadn't already adjusted or hadn't already reprocessed your observations and you hadn't started drawing a model, then you would just, because at the moment we're all still in local, you would then just highlight the yellow book and you'd go to reduction and rerun the reduction process. Okay, now we've got OS values in there, you just press OK, and now the whole job will be recalculated to sit in the OS values. But if you had a model that was already, shall we say, in the process of being drawn up, you don't want to obviously have to start all over again. So what you do is you can go to points, and you go to transformations, apply, choose the transformation that you just generated, press OK, and there you go, the whole thing's been flipped. Okay, so that's one way in which you can reprocess data, move it, or rather, that's a way in which you can apply transformation to a model once it's up and running. If you do Control Z, it'll obviously disappear. And if I reset my extents, double middle mouse button, it'll come back. Okay, so that's how you could, if you wanted to, move the coordinates of your data from a local grid system to whatever your survey grid system is. I'm going to just work on it like this now because it's going to be easier to understand. We've got these yellow crosses in here. They're there because Enforce doesn't know what to do with that code, SH. If I click on it and then try and click this button here to go into the code definition for it, it says it can't find it. So if we go to settings and I go to codes and I come down here, I have a code called SL set up for spot level, but this particular survey uses SH. So I could actually recode everything that is an SH to an SL. Let's just show you how you would do that. So in here you can see them here, right? So I'm going to right click and I'm going to go to select normal and we'll say SH and then put a star on the end, which means anything SH with SH1, SH2, whatever. If I now make sure nothing else is enabled, no, nothing is, so I should be able to press OK and OK, and it's selected all the SHs, so I can now right click and I can choose recode and I can now make those SLs. Okay, and if I now double click on the job, okay, so now we're only left with these points here that haven't been coded. Everything else is now behaving as a spot level. If I jump my scale up to say 1 to 500, that text will get a bit bigger. Okay. The alternative would have been to go into my settings, go to codes, find the spot height code, so find the spot level code, press add, and put in SH. So it would be completely duplicated, so it would behave exactly the same. So it's entirely up to you. You can either add a code, copy an existing one, and then set it up from there, or you can just recode your points to obey the code list that's in there at the time. So because I changed the default code to draw things in yellow, you can see that we have obviously still got some yellow points. So to get a better idea of what those are, I'm going to go to Features, and I'm going to come to the Report option and click Undefined. So now anything that hasn't got a definition is then highlighted for you. So we have this INV code. Okay, I'm not entirely sure what it's supposed to be doing, but it certainly draws a line. So at least let's set it up to draw some kind of a line. So if we go to coding, I'm going to make the code INV. So INV is the code, and the number on the end is the string number. I'm guessing that's some kind of invert. So we'll just say OK, and now we can then set that particular code up. So chances are we probably don't want yellow points for it, so I'll put them back to grey. And if I go to line, we will enable the line. Put it on the layer, say ground forms, and have it in a green line. And let's just go, if I press D, we'll go down to dashed. And that'll do us, I think. So press OK. Now that INV will disappear from the list, and it now shows us other codes. So it's got a hedgerows in here. If I go to the top, we've got an interesting code here. We've got a BLD. So that looks like a 3-point rectangle of sorts, doesn't it? Because you've only got 3 points for each of those. So let's set that up to draw a rectangle from 3 points. So I'm going to go to coding, and I'm going to call this one building, and we'll put 3 points on the end. Just so if you ever need to use it again, you'll know it's going to, the description tells you it needs 3 points. So let's put that back to grey. And we're not going to draw a line, we're not going to draw a symbol, we're not going to draw any text on it, but we are going to draw a shape. So I'm going to enable the shape, put that on the buildings layer, and we're going to say a 3-point rectangle. If you want to, you can hide the second points and just press OK. And if I just press OK again, there they are there, look. Okay, so I've hidden the second point. So if I click on that button there, and I say, oh, I didn't actually want it in red, I actually want it in say magenta. Press OK, OK, and they'll just update. Okay, so changes to the code table global, they'll happen absolutely everywhere. So we'll assume for now that the code table is set up. Obviously we've still got some yellow points, that's not quite the case, but I just want to carry on now and actually do some sorts of edits. First thing I want to do is deal with a situation where maybe I've got some points that should maybe have been coded a different code. So let's argue that these points here should maybe be a fence instead. Okay, so to do that, I'd go to lines and I'd go to create. And essentially this lets me do a dot to dot. So let's take this point here. Okay, so I want to apply any changes that I make to all other points. I don't have to keep I don't want this box to keep coming up, so we'll enable that. And I want to recode them. I don't want enforce to duplicate them. I don't want multiple points here with different codes. I just want the 1 point with 1 code. So I'll hit recode, and then we're going to click on that point there, that point there, that point there, there. Okay, and I'll stop there for now. And then right click, and it says what code you want. I happen to want it as a fence, so F will be fine. And there we go. There's our fence done. There are some codes here that look like they may need to be joined. So if I go under the lines tab, we've got a query here, so a query line, click on that. Yeah, it's highlighting the whole thing, so that should be closed. So if I go up here and use close, that sorts that out for me. Now obviously there's places where our annotation, which is being aligned parallel to the feature, is going to do this in the corners. So you have some options. You can obviously change the way it's annotated, or we could say maybe flip it. So if I was to go to the annotation tab, and if I go to feature, because it's on a line, flip height, click that, it'll just jump to the other side. You might just not want annotation sticking out in that particular way. So if I just right click, so I've got no commands, click on that point, click on the little button with 3 dots, and if I go to the height tab, which is enabled, and change it from say parallel to say parallel leading, press OK and OK, then it will do that. So it moves it for you. Okay, so it goes to the next segment, to the next leading segment. It might still be that there's places where you just don't want that annotation. Okay, so it might be that we don't want that one there. So if I now go to annotation, if I go delete height, and not in rectangle mode, in element mode. So I'm going to delete this one here. Again, if I hover over it, you see because I've got hovering enabled, it shows you which one it's about to delete. So you don't click on the text, you click on the point. The other thing that you may want is to not leave a cross or a survey point behind if it doesn't have a height. Now at the moment all my heights have been drawn the same size, okay, but if I enable an option here that says real point size, okay, they'll get bigger and smaller as I zoom in. Okay, so if I use the option that says dot on delete and remove this one here and just do something to update the view, like zoom in or out, you can see it actually changes it to a tiny little cross. So that way you don't have survey crosses on the screen without a height anywhere near them. And you can do that in element mode, rectangle, or list mode. And list is just a way of tagging points, but that's beyond the scope of this little video for now. If you just want to move a single point annotation, so if I was to go to move height, I want to move that, I could put that there. And if I wanted to reorientate it, the easiest way is to go to slide rotate and then just click on it again, so move it to there, and then you can reorientate it that way. That command slide rotate is only in Pro and Designer, it's not part of Light. If you do Control Z, obviously you can undo that. And even if you delete the height, which we have done from this point here, all you're actually really ever doing is just turning the height off. It's not properly being deleted. If I wanted it to come back, you just use the restore option, and I'll just say restore height, and if you're not sure where it is being done, you can just say just rectangle that area, and then it'll all come back. Okay, so it's entirely up to you how you obviously want to tidy up your text, but you would generally use the point, delete, and move and rotate tools to tidy up individual pieces of text, or use the feature, which basically is on a line, to flip on a longer section of features. There's probably going to be parts of this survey here that I might need to join. So let's look up here. So yeah, we've got some features here. So right. So if I go to lines and I go to join, I just have to go from that end to that end there. Okay. And say from that end there to that end there. And that essentially joins that feature and makes it one. If I were to do it to a feature that was a different code, so if I come down here and just for argument's sake, obviously we wouldn't normally do this, but let me just join this one to this one and watch what happens to the fence. Okay, that second one becomes the fence because we've joined it, we've made it one continuous polyline. So I'll do Control Z to undo that. If for whatever reason I wanted that feature to run into that point, that would be an apex append. So under lines, we'd go to apex, append a point, and we basically click on that feature and then we click on that point there, and we essentially tell the system we want to duplicate that point, and then right click. Okay, and now that's running into it. If we have a corner that we need to extend, maybe there's a corner point here that we couldn't get to, that would be segment, and then we're going to do merge fillet on that. And you can say move on lengthen, which actually takes the 2 points out and just leaves you with one, and then how you want to calculate the height. So I'm just going to leave it on average for the time being. And there you go. So that's how you would insert a hidden corner that you may or not be able to get to otherwise. Down here where we've got our new fence, that new fence may, for whatever reason, need to run to that feature there. So that would be an extend. Again, Light doesn't have all these features. I think it has a simple indicate, so we can just drag it manually, but I'm going to drag it, rather I'm going to intersect it to a feature. So just a single line here, and I want the height to be calculated from wherever it hits the second feature. So if I say second segment, and I'm going to say move on lengthen, so it actually moves the point. And if we say pull back a millimeter, that means when we create the DTM, we won't get a crossing feature issue. So if I hit that feature there, and then click that segment there, it'll extend to it. So it's important you indicate the segment you wanted to hit, because polylines could have potential multiple crossings. So you need to indicate the segment where you actually wanted to hit. So because I've got it set to real point size, as I zoom out, you only start seeing the features. So if you want to see the points come back, just turn real point size back on, and then you'll see the whole job as before. So I'm going to assume for now that I've tidied up my line work and I've tidied up my points. And what I want to do now is create a ground model, DTM. So to create the DTM, I'll go to DTM and we're going to go create normal. It warns me about any potential crossings I have, so that's fine. I'm not going to worry about them now. You can tick generate report and plot errors to actually see where they are, but I'm not worried about that for now, so I'll just press OK. And then based on your contour settings, Enforce will now draw you the triangles and contours. The contours can be turned on and off here. Okay, these are what we call our on-the-fly contours, and your triangles can be can be unticked by unticking the model option if you don't want to see those. So contours at this stage, the ones that you can untick here are what we call quick draw contours. They will update on the fly. So if I right click, so I've got no command running. If you right click, if you hold down Control and Escape to clear the menus and then right click, or just Alt M at any time, you will see the right click menu, and that will show you previous commands that you've been using. So you don't always have to go up to the ribbon bars. If you do Alt M at any time, you can see the previous commands. Okay, so that just helps you that helps you speed up the way you work, because you don't have to keep going out to the ribbon bar. And then click a point, say for instance that one there, I was to do something daft with its height, let's set it to 100, press OK and just move the screen. There you go, it updates. Okay, so these are contours that will change in real time as the surface changes. Obviously Control Z will undo that. To change your contour settings, you'd go to Contours and come down to Defaults. Okay, so I've got mine set up to draw a highlight in dark blue every meter and a normal every 200 millimeters. If you'd rather, shall we say, have the highlight every, say, 5 meters and a normal every meter, you just make that change. Whilst I'm in here, just a point of note, the text offset is 0 for both of these intervals, which means that when I annotate them in a minute, it will break the contour. Because I'm annotating it every meter, essentially, I'm going to just leave the decimal places set to 1, because I don't have to worry about half or quarter or anything like that. And if there's any tiny little parts of the survey where it's going to get a little loop, like a circle around a car, so if you're modeling data from a point cloud, this sort of sets the size where if a contour loop is smaller than this value, it'll just ignore it anyway later on. That being said, so if I just press OK, we should get less contours, because I've obviously changed the interval. If I untick models, or before I untick models, I need to delete the areas where I don't want those contours. So if I go to DTM, and I'm just going to go delete by a single strike, take those out of there, and maybe you don't want that big one in there, who knows. Okay, if you make a mistake, okay, just do Control Z and it'll come back. So at some point we want, I'm going to take this one out here. Okay, so at some point we want now to create presentation quality contours. So I'm going to turn off the DTM and zoom in. So it's very important that you zoom in so that you can see the text, because this next stage requires the text to be drawn so that it can break the contours, because it needs to know how big the text is. And if you don't do this, you'll get some funny results. So what I'm going to do first of all, then I need to create what we call threaded contours. Threaded contours essentially are just Cadd polylines. Okay, we can't curve contours and break contours in real time and update the surface. It would just be too slow. So when you are happy with your DTM, you then do this stage. So you go to contours, and we're going to come to threads, create. Same settings as before, because it essentially is the same kind of thing. It's just these contours are going to be permanent. They're not going to change as the surface changes. So I'm going to just press OK, and nothing really seems to have changed. Okay, but the difference is that now the contours no longer live here. You can see it's been turned off. That was because I had this option here that said override quick. So override quick will turn off the quick draw contours. Okay, and they now live in the Cadd backcloth. Okay, so the Cadd backcloth is like a hidden layer or a hidden view on top of the model, which you can get to, if I zoom out, by hitting this button here. And that just draws the Cadd side of the software, i.e. information not drawn by the code table. So if I was just to go to, say, rectangles and draw a rectangle, okay, and go to circles and draw a circle there, okay, if I right click, there's no command, I can click on it and change its properties like in AutoCAD or wherever, but it's just drawn now. Okay, it's just drawn dumb Cadd, and if I move this view, you can see the model data updates. Okay, so obviously I don't want those in there, so I'm going to hit Cadd again and do Control Z, and that'll just get rid. The screen is going to flicker a bit because I've actually, when you've got the both open like this, it'll update both at the same time. So sometimes it's a good idea to put the model view or the Cadd view on another screen. But we don't actually need the Cadd view open anyway, so that's just to show you how the Cadd backcloth works. But we do need to annotate these contours, right? So we're going to go to contours. Okay, now if I was to do annotate by, say, strike and just click a few contours like this, okay, you can see it's broken them as we wanted it to. But if it's a big job, you might want it to do it automatically for you. So if I say delete all, and if I say by distance, and then annotate every single one, shall we say every 50 meters, we now have every single contour annotated. Okay. One more thing I think we need to do before we can create a PDF of this is to create it, or rather drop it onto a sheet. So I have a layout already created. So we can import layouts from AutoCAD, and we've also got a video on YouTube how to create your own. So this one here shows you how to create your own layout from scratch. But for now, I'm just going to skip over creating one from scratch because I have one already made up. So if I go to layouts and I do 1 point, now I'm going to use an A3 sheet. For now, it's set to auto-fill text, which has been essentially needs to be filled in. 1 to 500 is not going to work because this data is quite large. So I'm just going to guess at 1 to 2000 because I just want to fit it all onto one sheet for now. Normally you probably do a series of sheets on data this big, but for now I just want to put it all on one sheet. It's going to auto-fill the text, and it's going to ask us about whether or not we want to put a grid on it as well. So I'm going to just press OK. So we will need 2 sheets, it looks like it. It's even 1 to 2000, it's not enough, so let's put 1 sheet there. So okay, sheet 1. And we have the title, so let's call this one Demo Video. No comments, put a number in like that, drawn by Phil, checked by me. Revision 1, number 1, and then press OK. And it says I haven't filled in all my fields. Are you sure? Say yes. Okay, and now it wants to know how big a grid you want to put on it. So because it's a big site, I think 50 meters would be too much. So let's say every 100 meters. I'll go for solid lines in a dashed line style. So the standard settings will probably have a few more intervals in here, so you might want to remove those. I'm just going to leave it on normal and press OK. And now because we've done that, we can put our second one down, and we'll call this one sheet 2. All right, now I'm going to cancel this stage because I've already done it. I can copy them forward, so I'm going to just cancel and OK to those settings. So what will happen now is if I come out of here and go to my sheets, you see under drawings, sheet 1, and there it is. Okay, and if I look in here, okay, so I actually didn't fill in the comments, so what we'll do is we'll just delete that, edit, and we'll go delete, and in rectangle mode, I'll just draw it like that. There we go. But otherwise, you can see we've got our grid, everything else is looking okay. Probably want to put a legend on here, so it's not going to be a fully functional legend because it won't include shapes and things that I haven't set up yet, but it'll just do the basic line work that does exist at the moment. So if I go to Tools, I have to click the viewport. I've been selected Tools, I'm going to go to Legend. Those are the items it's going to annotate that I've got in my survey. Press OK, and we'll just drop that down in there. Okay, so that'll do for now. Close that on down. Okay, now because I've annotated this one already, sheet 1, I want that same annotation to be put onto sheet 2, and I just need to change the sheet numbers and stuff like that. Sheet 2's already got annotation, okay, on the text layer. So what I'm going to do is I'm going to delete the text layer and then copy and paste it in from the other sheet, and that way I won't have so much to do. So if I delete that one, so I'm going to just right click it and choose delete. Okay, and then we go into here, and the default layer's got the legend on it, and if I highlight that one as well by holding Control, right click and choose copy, go to sheet 2, right click and choose paste, and then double click on it. There we go. We've got pretty much everything we need already here, and we're just going to change our sheet. Okay, so now I can just change my sheet number, so I can say 2 and 2. And obviously make that small change as well on this sheet. Okay, so that all being said and done, we've pretty much now got a couple of sheets set up, ready to go. So if I wanted to export these, we just select them like this, right click, and I'm going to choose export. We'll just call this one video demo. Save. So currently these settings stand, everything's going out in 2D, but let's send it out in 3D. So if I go output 3D, we'll say, yep, that's an okay version, modern version of AutoCAD. So anything like a complex line would normally be sort of now converted to a solid line in AutoCAD, because AutoCAD doesn't support complex line styles in 3D. So to get around that, what we can do is we can say anonymous blocks here on the complex line style section. That essentially explodes it into lots of little short straight lines and turns it into anonymous blocks. So it'll look the same, it'll be 3D, but it just won't be a line style. I'm not sending out the triangles, but if I was, you'd probably want to use polyphase mesh, and we'll use true type fonts instead of getting AutoCAD to swap them over. So we press OK on that. Now, if I look at it in true view, okay, so there's our model, okay, and there's our two sheets. So we got sheet 1 and sheet 2. Okay, now just to finish off, I'm going to put some sections on this and create maybe a section sheet as well for us. So if I go into our model, I'm going to start just by putting a simple long section through this area here. So under sections, I'm going to go to long section. I want to see the triangles and I want to see the features. I'm going to sketch my line. I've got no other models to go through. So just press OK, and I'm just going to say click there, and then click there, and then right click. That's been exaggerated 5 times, so let's drop that down to 1. Okay. If you want to see a drop line, so we turn on drop lines, you can see that. Now these are just drop lines wherever it crosses a feature or a triangle. If I turn on codes, you'll see the names of any features it crosses. This is just a simple preview. It's not intended to look like this, okay, when it's finished. If I move my section over, and you can see now it shows you where you are in real time. So this essentially is a kind of a preview window just to kind of show you what the kind of thing you're going to get looks like. Because if there's a problem in here, then obviously you can go and fix it before you then go to the next stage. This is fine for now, so I'm just going to close that down. I'm just going to call this all L-sec1. And before I forget, I'm going to plot where that section goes. So I'm going to go section lines plot. That's my long section. Let's have it in magenta. Fill the end symbol, press OK, and there you go. So that's where our section is. Okay, that's a simple long section. But let's say, for argument's sake, that we wanted a series of cross sections to follow this. I think it's a road here. So for that, we'll go to sections, and we'll go to multiple cross. We're going to say from a feature. I want to go through the DTM and through the features, and left and right, say 10 meters should be fine. Every 5 meters, and we'll press OK, and then I'm just going to click that line there. Okay, so you can see here's the preview. Okay, and then if we hit next, okay, or we can use Z and X to go through. Okay, if you decide those aren't wide enough, you just cancel that, and then we can go back to cross sections and say I want to go, say, 25 meters either side. Okay, then press OK, click the feature again, and there we go. Okay, so it's up to you on what you want to use for your settings. But if you're happy with your setting, section, close it down. Sec 1. And again, we'll go to plot cut lines, and this time we'll go for our cross sections. Press OK, 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 and that's what our cross sections. Obviously, it's a bit overkill for now, but it's just to demonstrate what's possible. So we've got our long section and we've got our cross section. Now I need to plot those sections. So we need to do that maybe over here somewhere. So it's in the same coordinate space, because if you don't do it in the same coordinate space, then when you get into AutoCAD and do a zoom to extents, they're just going to end up with 2 small dots on the screen. So go back to the Home tab. I'm going to go View CAD with Model. Minimize that so the screen doesn't flicker because it's all on one screen. So now I'm in the CAD side of the software. So we're working with our text scale at 1 to 500, but when we actually plot our sections, they will be actual size. Okay, so under sections, I'm going to start off with plot single. There's our single section. Okay, so this is a preview, right? So you probably want to increase the size of the box below and above. So let's go from, say, 76, and let's then take it up to, shall we say, I don't know, 120 for argument's sake. That's probably a bit high, say 115 instead. Okay, that'll do. Now all our annotation is currently in red. There are settings to get the text to change based on the color of the surface it's cutting, but for now I'm just going to go to the Profiles button, and rather than say red, let's have it in kind of a green, and we'll have all annotation in white. So if I click in here and press white, sorry, W, it'll just jump. There we go. Now if I go to the Defaults tab, and if I go to the lines, so at the moment I've got everything plotted. I've got the frequency set to all and an option that says flip and clash here. Okay, so essentially any drop line where it crosses a triangle side or a feature is going to give you a drop line. If you have two drop lines coming down close to each other, then it will clash them. So it will try and flip them so that it does that. But if they're really, really close and it can't fit them in, it will just clash, which means it will just delete the text. But it'll only do that when it comes from a triangle side. It won't delete text from a feature. So I think that's going to be okay for now. Okay, that's the layer name for the section, and we'll just put this over here somewhere for now, and then roll it all in. So if you wanted to now, so say for instance you didn't want both of those, under sections we can go drop line delete. Do I want to delete the node up here? No, I don't. And then just select the one you want to delete and that'll go. Okay. Or it may be that we want to, instead of doing that, you might want to bend them. So if we do bend, it says indicate the datum, which means a point, a height. So be careful what lock mode you're in. Don't click on something, otherwise you get the wrong height. So I'm going to say click here, just in an empty space. And then it says indicate drop line to bend. So if I click on this one here, I can move that out like that. And you notice it moves the text. Whoops. Need to undo that because that now overlaps that one. So let's just do that a little bit less. There we go. Obviously you've got multiple surfaces. That'll make life a bit easier for you. There are tools that kind of do that automatically as well. But for now I'm just going to leave it on the manual mode. And now we'll try and do it for the rest of the sections. So we'll go multi, all of those sections. Okay. Obviously I don't want it in one great big long column. So let's try and maybe fit 10 into a column. We have the same defaults as before. If you don't have it on height based, click it on height based, and this allows you to put a minimum height below and above. So we've got 0.5 meter below, 2 meters above. That's just about enough, but let's maybe say make it 4 meters, just with a bit more room. So click off in the box and then just zoom in again. We might not want the coordinates here, so if we go to defaults and go to plot, we can say none across the top. Okay. And we probably also now want to plot the code if we cross a code of any of these. So I go back to defaults. At the moment we're only plotting the level and chainage. So if I press define and then I move the code over there, and there are lots of other items you can annotate. You can annotate depths, differences, surface materials, all kinds of things. But for now I'm just going to use the code, double click on it and say plot on profile. Press OK and then OK again. And if I zoom in, there you go. Then we go to profiles, and then it's the same thing as before. So because it's a completely different section, it'll have different settings. So let's make it green again, and just W for white in both of those. Press OK. I think that's OK now. Press OK, and drop them there. Okay. Each of these will be plotted on its own layer. So if I click on layer, here you can see all the layer names, so that it keeps them itemized or keeps them separate for you. If you want to make a change, so at the moment the name of this data is not great, it just says AIC Trav Local. Maybe I want to change that en masse. So if you go to text, okay, and then we're going to do a replace. So AIC underscore TRAV space local, and we'll just change that for quarry. There you go. Okay, so everything's now changed. Obviously it's changed it here as well for that one. Okay, and then one last thing I want to do is I just want to put these on a sheet, and then we'll output that to DWG and also a PDF. So if I close this view down and pop up the model view, okay, you can see they're still there, okay, because we're looking at the model, and the model contains both the Cadd and the model. If I were to untick Cadd here, okay, it will go off. And if we were to output a DWG or PDF, it's what you see is what you get, okay, so you need them on to be able to see them. So let's put another layout down. So go layout 1 point. Use the same kind of sheet. Let's say 2500. And see, we don't worry about a grid. Not going to worry about filling any text for now. And that just fits. So we draw some of the section plots. Press OK. And if I close that view down, there we go, section plots is there. Okay, and then to get it all into one again, we go to drawings, select those all, export, update that one, Okay, and there it all is with our section plots layout. And then finally, let's just put one of these out to PDF. So let's say this one here, double click on that one. So we'd go, here we go, Adobe PDF, sheet 1, yep, okay, save that, just leave everything as it is, and there you go, it's the PDF. Okay, and that concludes this presentation. I hope you find it helpful.